So yeah, thank you very much for having me. And as I said, I'm going to focus on the Alaska Climate Integrated Modeling Project. You'll see what that's all about in just a minute, but then talk about some other related issues also. Is there a clicker here? Any of these work?
Well, can't find it.
Okay.
I was here yesterday.
Okay.
Someone seen the clicker pointer? No.
All right.
So you can, if you click on there, back on it, you can click there to change slide.
Okay. Is there any other way? There we go. Okay. All right. So just big picture. I don't know if you saw this. The National Climate Assessment in the United States just came out on Friday. So it was sort of buried by the U.S. government, arguably. But I didn't say that. I don't know. But the Friday after Thanksgiving. But I worked on the oceans chapter. And so this is you can look online for this, the National Climate Assessment. There's a lot, so it talks about this across all ranges of U.S. society and the regional chapters as well, but there's an oceans chapter. And so there's sort of these three key messages to this, which, one, not surprising, we expect ecosystem disruption to intensify unless some action is taken to mitigate, reduce carbon emissions. And then in the marine fisheries sense, and this is what I think is really, this is where I was focused a lot, is, there are going to be real challenges through ocean warming and acidification that are going to affect fisheries and communities, but that we have tools to deal with this in some way. And so that's an important sort of the upswing of management matters, that in the context of a changing environment, you really have to think about how good management can help address some of these problems. And then other key message, we focused a bunch on heat waves and extreme events. And there's been a lot of exciting work done in this area, as many of you know and are involved in. But also, again, this is something where the things to think about this with new tools, where we may be able to address, to build forecasting products and work with management to think about how to address these extreme events better. So I'm not going to say too much about the U.S. I'll come back at the end of the talk a little bit about a few things. I know you heard some different regional examples about distributional changes, and so through NOAA Fisheries and NOAA more broadly, we are trying across the whole country to sort of look at what are the things where we don't know things and we need to fill in our scientific gaps, and try to take the things that we're learning in different regions and apply them elsewhere where possible. But the key question really that I've been focused on in this, we've been talking about this about in the mid-2000s, there's an organization, the North Pacific Research Board. So sorry, that may happen. I thought I'd taken away all of my forwards, but it may be on autoplay here. In the mid-2000s, the North Pacific Research Board set up this big project to look at how climate change is impacting the Bering Sea, and said, okay, what do we know, what do we not know, and set up a structure of integrated modeling. I had a role in that project as well as being involved in the integrated model. I was working on in a parallel sense, say, okay, let's just look, all right, how are fisheries being impacted directly by changing environmental conditions, and looked at the pollock and cod fishery. But that big project lasted from 2008 to 14. And at the end of that, we said, okay, how do we operationalize the things that we've learned into fisheries management? And that's what ACLIME, the last climate integrated modeling project, is about. Nan Hollowed, who has been involved in SICME and the Strategic Initiative on Climate Change, and Kirsten Holzman are the lead PIs on this. But Paul, oh man. It's funny, I don't know why I took out the plays, but they're still there somehow. Paul is involved in this, and Christine's has been involved in this project as well. Large group of people from NOAA and the University of Washington and a few other collaborators. And the idea here is that we're trying to integrate this whole system, our understanding of how the physical environment's changing with things that we know about how climate affects different organisms, and then affect and then change the management system where appropriate as a response. So that we've worked with managers throughout this process, and we're regularly working with people in the fishery and with the different management structures, the Fisheries Management Council, the state of Alaska, and other managers to try to adapt what we're doing to the things that they're most concerned about. And the the kind of key idea here is what we're projecting the changes in ocean conditions, and then we're looking, okay, how does our current management, sorry, this is going to go on all the time. You see this little flashback. How is our current management set to deal with this, and what can we do to improve it? And so the big picture, all these people you see, there's the element of physically downscaling projected changes in the global environment to the region through a ROMS model, and then coupling that with different biological models that have different levels of complexity, and then connecting that to how that is going to connect to impact fisheries and the management system. And then we can think about, okay, given what the management issues are now and these projected changes, what should we be doing now, and how do we make our system more flexible and adaptive going forward? And a lot of the initial effort was focused on this, this physical to biological linkage, and had a lot of great collaborators there. And then now we're more focused on this coupled socio-ecological system of looking at, okay, how are people reacting to these different observed changes now, and how are, given the projected changes, how can we understand what the likely outcomes are going to be, and then give feedback as much as possible to the managers. But as you know, a lot of this is uncertain. We don't. It's not that we're going to be able to give people the answers, but rather signals about, given the things that we know, how to help people make decisions and make the management system flexible where possible. We have these two different scenarios. We wish that we had more, but these are general carbon emissions scenarios that we then run through all of these models. Ice is a fundamental part of the Bering Sea and drives a lot of the system. And we've seen in recent years that there's been a significant decline in ice. And if I showed you, down here in 2018, this blue area is the cold pool, as we call it, which is the presence of the presence of cold water that persists after ice melts. So this stays all the way through the summer. So the dark blue is the coldest water, and then below 0, and then below 1, and below 2 degrees. And so this really has a big impact on productivity in the system, and fish avoid, pollock and cod, the most abundant species, will avoid this coldest water. So in some cases, then the fish will be concentrated out of that. 2018, there was no cold pool at all this summer, and we don't understand what the system is going to look like in the future if this really becomes the norm, which is what's expected. This shows the 2017, 2018 decline. I was out in the Bering Sea in February, and weather was better than it is here today. This is the projection, going forward, of the models involved as well as the scenarios. So this is one of I'm sorry, actually, I don't know if I can stop it. Sorry about the forward autoplay here. I don't think if I stop, I'm not sure I can figure it out quickly enough. So this shows the interaction of the 8.5 and 4.5 scenarios, but also the different models. And this is something that is a challenge when there's not one answer. You can see there's a lot of variation year to year. If you run different models and different scenarios, how that impacts different species. So we're trying to capture the uncertainty at this level as well as later in the biological system. And through SIGME and other forum, we've talked to try to make what we're doing compatible with the other things that people are doing around the world are doing. So we're comparing the same models, but this has been more challenging than you might think for various reasons. People have different legacies where they have involvement with different physical models. A big change that we've seen recently, so I don't know if Paul, if you talked about this yesterday about the Northern Bering Sea. Did you?
I was going to talk about this a bit with Paula.
So this is the survey area in the Bering Sea, and this is the Eastern Bering Sea, and the Northern Bering Sea to the, I can't see that online, to the upper right. And what this area is closed to trawling, to bottom trawling, and what we've seen in the last several years is both pollock and cod have moved up here. Cod this last summer year, 50% of the biomass shifted north, which we've been quite surprised by this. We thought, given the cold water, that we wouldn't see this type of and there's some, I guess, some salinity issues that we thought would restrict the movement north, but we've had seemingly this big shift north. We don't know because we've only had surveys in the Northern Bering Sea in 2010 and recently in 2017, 2018. So a big challenge for us right now on the management side is okay, now that the fish are up there, what does this mean about, we have this great history of surveys in the Eastern Bering Sea, pretty minimal information in the Northern Bering Sea, and we don't have a good understanding of what mortality and other features of growth and other biological characteristics of the fish are going to be in the Northern Bering Sea, because we just haven't seen it. So that's suddenly become a major challenge for us that we didn't anticipate really would happen this quickly. We knew this was as the long-term forecast was to see significant melting in the Northern Bering Sea, that we would that this would happen, but it's become within 2 years has become one of our major challenges in management. This is from earlier work that I did with Lisa Pfeiffer in the Bering Sea project, and this shows you again the cold pool, and this was a question I wanted to ask when you were speaking to her earlier about how much you're talking about the fishery response to these changes as well as the the shifting distributions, because it's not just obviously vessels have ports that they're constrained to, but that limits their ability to go certain places. But in the Bering Sea, this is the cold pool again, the presence of cold water. And what we found is that because pollock and cod will avoid that cold pool, we actually in some years have seen the reverse of what you would anticipate, not the shift to the north with year by year, but the opposite, where in the colder years there's been more fishing in the north, because this area here along the shelf, fish get concentrated in this area by the cold water, and so the fishermen go travel further to those areas because the fishing is so good. So it's really important that you think about these economic characteristics along with just the biological shifts that may be happening. Okay, back to to ACLIMB. So after we developed this integrated physical model, this has been linked to different biological models, and then what we're trying to do on the socioeconomic side, we can't do everything. You can't we don't know what's going to happen to the pollock versus cod price in 2024, or that we can contemplate different ideas. We can have forecasts, but there's a lot of uncertainty in what those are. So what we're trying to do is to reduce that down as simply as possible and have different scenarios that capture the key directions of this. And there's not one answer to what's right, so we're trying to experiment with different variants and see what gives us surprises. These shared socioeconomic pathways are part of the IPCC process. I don't know if y'all talked about these at all yesterday or not, but this is a way, these sort of large-scale reductions of what may happen to the global economy. And one of the things that we've tried to do in different workshops is to map these down to the fishing process. And we had a meeting last summer in DC. We had a previous one in Brest in 2016 where we did this, and got a lot of insight. There was a paper that came out, this Oceanic System Pathways paper by Mari et al. That tried to do this and again have these scenarios. But for us, what we've realized is that
request because it's too slow.
okay, is that that didn't give us, we could think about those global scenarios, but we had to downscale these to a regional level to think about what are the specifics that are going to impact the markets and the biology in the North Pacific. So that's an ongoing effort really, where we're John and Myron and others are involved in this process of trying to think, okay, how do we take all the things we're learning across these big integrated projects and understand what's comparable and what's not. But for us, in thinking about the specific scenarios, we had to go into really more regionally specific, both scenarios of what the types of changes that are happening in markets and in fisheries, and then couple those with tools that we have available regionally. Should you close certain areas? Should you allow quota to be flexible across different species? A lot of specific questions that impact us, and then look at the impacts on stakeholders and communities so that managers can make informed decisions about how they choose tools that they think will be best equipped to deal with these changes. So these diverse biological models that are part of the system. So we've put together these are single species models. CE is climate enhanced. So they're single species models, multi-species models, ecopath with ecosystem, a size spectrum model, and then a full integrated spatial biological model. And the single species models are fast, but of course they don't have the level of complexity that are in the more complex models, but the feast is really is quite slow. It takes months to run this fully integrated model, so we can't think about all of these scenarios. So what we're trying to do is understand through these biological models and the coupling of them to economic models, what are the implications what can we learn and understand about the uncertainty and relationships across these different models. And so we've presented to stakeholders a lot to try to get their take, and I'll come back and talk about how we then use that on the economic modeling side. So we've done a bunch of presentations to the Fisheries Management Council. We've done interactive questioning with different stakeholder groups. And then we've adapted what we're doing to their feedback. And a key part of all this, I think, is that managers don't understand all of these details when they first see it, and so that you really have to have this long-term repeated interaction. And so I think that's kind of this is something in talk tomorrow night, and that's a message that I'll say is like this can't be something where you expect to kind of tune in for a little bit, understand everything, and figure it out. Either from the scientific side, you can't really understand what the stakeholder preferences are, and from the industry side, they need to be deeply engaged in a way that lets them learn and give us detailed feedback that then we can understand. And it's not as though they know the answers to begin with. You'll go to people in industry and say, well, what should we do? And the people have answers to that, but my experience here has been that's a novel question to many people. And so you have to keep asking that, exposing people to new information, ideas, and then you start to have a richer dialogue and understanding about what different needs are. We ask in these interactive structural interviews, what are the things that people are concerned about? And this was at the evening at Fisheries Management Council, and it was different people took it to different degrees with different degrees of seriousness. But a key thing that came up is this idea of too much rigidity. That as things are changing, we've built fences around different fisheries, And that's a key message. We hear that over and over and over again is we have so many regulations we have to deal with, and now the fish are shifting, what do we do? And so we're trying to think, all right, the rigidity is not useless. That the reasons why it's been put in place is because you have different management objectives that you're trying to control effort or protect different species. But there are ways in which we can reduce unneeded rigidity that really can allow different groups to adapt to the changing environment. So with these different biological models, in some cases that there's an effort response is really all that how much fish are you going to catch, and then in other cases we really want to understand, okay, where is the fishery going to go, because you care about these refined spatial questions, and then we care about communities. So in the ACLIME process, it depends. In some cases we're just estimating the amount of catch, which is actually harder than you might think. And in other cases have more robust economic models. This is a project that I've worked on for several years that allows different models of fisheries to be integrated with different models with different biological models. And so a big effort we're trying to have these standing models of all of our larger fisheries, so that then as we learn more about how we expect the biology to change, we can couple that with these economic models. On the scenario side, this is a piece of what we've been working on, of trying to reduce the number of things that may change down to few enough that we can build a finite number of models, but also capture the key features. And these are a group of scenarios that we've run, and you can see why the reasons why some of these things may change in either direction. So fish prices, consumer demand is increasing, but then at the same time, some species are competing with aquaculture, so prices may go the other direction. So you can't think that we know that prices are going to go in one direction. Changes in the relative price of premium fish to basic protein is something else that we've looked at. Number of species fished, costs, and then some questions of management priorities. How much we're prioritizing conservation, how much we're protecting specific fishing communities, maintaining their share of fisheries, and then revenue volatility. Do we want our fisheries wanting to go after opportunities when they happen, or ensure that there's a more fixed level of income? And there are reasons why all of these may go in different directions. So we're starting with a suite that looks like this, but we can actually compress this down really into a smaller number of options. And we have then within our system is sort of 6 different levels of, or six different policy processes that we're considering. And so when we run these different models, we're considering the variance of these along with these larger changes in economic variations. So our first run of this, and what I just showed you is sort of our roadmap of we're going to explore all of these over the next year. But we've set this up, and Paul's run this himself, and so his models, this basic idea of we're going to say, okay, we're looking at no fishing setup, a current ecosystem management. So we have this 2 million ton ecosystem cap in our system, and so this has a really big impact on the way that we do things, because often the single species level is much higher than of all of the species. Might be 4 million tons, but we can only catch 2 million tons total. So that's a major issue. That means that you can't, even when one species has like pollock will often be above 2 million tons, and it's not all caught. And that was set up in a kind of complex history of why it's that way. But this is a big part of our management system. But the 2 basic scenarios that we've looked at is just increasing pollock and cod and increasing flatfish. But because of the 2 million ton cap, this ecosystem cap, this isn't just we go out and catch more. We're not catching the allowable biological catch now. So this means really a policy shift of moving one direction or the other towards more flatfish or towards more pollock and cod. And this is what stakeholders express is like that's our sort of core decision that we have to make. And one thing that's interesting about this, these price and change storylines that I showed you, these map into these where there are different reasons why we might shift to the pollock and cod world or the flatfish world. That this could be either that the relative prices of these species changed, or these are also species that are restricted by bycatch, so that there's concern about halibut and Chinook bycatch that's caught along with targeting those. And so the relative prioritization of the bycatch concern also impacts this. So, you saw all those complexities of this, maybe about prices, maybe about costs, and maybe about bycatch, but to some degree it just maps to, all right, given our 2 million ton cap, are you going to shift more towards pollock and cod, or are you going to shift more towards flatfish? And that's what is sort of a key element of this scenario exploration, is mapping all of those different features down to something that's tangible, and this gives us an ability to do that. Part of this, though, because the 2 million ton cap, is we have to predict how managers are going to choose to allocate species. It's not just that how many cod are there going to be, are we going to catch them? The council then decides, okay, given the allowable biological catches that we can't exceed, how much are we going to allocate to one species or another? So that's a political decision based on the biology. And Amanda Fegg, who just had a baby last week, and so this work stopped for a little while. So she's worked on looking historically at what the council has done given different allowable biological catches. And so this is I can't see my legend very well, but so the red here is the actual, this is pollock historically. So going back to, so predicting out of sample based on all of the other years. So that it's the actual, and then, this is the predicted level, how well we can predict what they do. So we take an array of all of the different species that are under the 2 million ton cap, and then estimate that, all right, what would the council do in terms of what would it set the total allowable catch of pollock given the biological possibilities. And so we do this for all the different species. And why does this matter? Well, when we're running forward, what happens isn't just going to be about biology, it's going to be about this management process. Because things are constrained by this 2 million ton cap, the catch is not going to be equal to the allowable biological catch. The TAC is going to be set below the ABC for most species, and then we can also estimate, given the second stage of this is estimating how much catch is going to happen given the total allowable catch. And because of bycatch constraints and different, fish are not always available, you may set the TAC at a certain level and it may or may not be caught. So we're able to then predict that going forward. And then these are these two different scenarios. So there's a higher pollock cod scenario or a lower pollock cod scenario. This is what we would have historically, tweaking the scenario based on what was actually done, and then these scenarios. And so then we run those forward through all of the models, and this is the EcoSim model. And so you can see this is this is pollock cod, arrowtooth flounder, and yellowfin sole. This is for 4.5 for the RCP 4.5, and this is the higher emission business as usual 8.5. And so these are these four species, and then this is the no fishing scenario here, the pink. And then this is the combination of the status quo and then the pollock. So this is, say, cod, and this is a pollock and cod, the long-term biomass from a higher amount of pollock and cod fishing versus a lower amount of pollock and cod fishing. So this is, we're not. This is preliminary work, but this shows how we can say, all right, what's the interaction of the changing carbon scenarios and the changing policy scenarios. And you can see across species this varies a lot, where for pollock, the specifics of the management decision overlap a lot with the carbon emission scenario. But for cod, it's more sensitive to the change in emissions and climate, and so that really has a much bigger impact on what's going on what will happen. Actually, sorry, I'm misstating that. This is the no fishing. This is what happens if you didn't catch fish at all. But sorry, I'm looking at this totally wrong. So this is the 4.5 versus the 8.5. So ignore what I just said about the climate setup. You can see that the no fishing scenario would have a much bigger impact on cod, and this is because this includes the predation relationships. We do have different through the different modeling efforts, we see that there is a very different species-specific response, to higher emissions. Where in some cases, and we try to be really careful about how we talk about this with species where in some cases some pollock models, the implications is it will decline quite a lot, but there's a lot of uncertainty about that, and so we've tried not to overstate how likely that is. This is a size spectrum model. We're looking again across a bunch of different species. John actually, he has a paper that's just been accepted about this in ICES. So we run through all of these different scenarios, through all of these different biological models, and then compare the way that uncertainties impact is going through about the climate versus the policy scenarios are impacting the different species. And then where I spend a lot of the time, my time is looking at these management tools analyses, where we're trying to figure out on the management side, okay, what do we do given all of these different uncertainties? And in some cases, there are traditional means of harvest control rules that we may be able to change. We maybe want to be more or less conservative under different conditions. There's predicting. We can't know all of the technological changes that'll happen, but we know that technological changes will occur. So keeping that in mind. Catch shares are a really major part of the North Pacific, and we've created these. In some species now, we have flexible quota across different species, where you can, as long as you don't exceed the allowable biological catch for some of the flatfish species, you can move quota across different species, and so that gives a lot of flexibility. And that really is linked to changing environmental conditions, because in colder years, some species are highly available, in other years they're not. And then we talk about different types of, we have 100% observer coverage in a lot of these fisheries, so we can have these bycatch reduction incentives that directly penalize or reward people for their bycatch behavior. And of course, we don't know all of the future changes. So we're trying to finish all of these different models, and we're publishing papers about the pieces and working on a synthesis paper now. And like a really key thing we're trying to present to the public here is that this isn't as though we're going to finish this project and it's going to be over. This is the structure that we can integrate into the fisheries management system long term and continue to revise and improve. And there are elements now that we feel pretty good about, and others where, all right, this is really basic. But that's kind of a key message and experience that we've had in this project, is that it's really essential that you focus on integration early. That you can't think that you're going to do all this work by yourself and then talk to the economists 2 years from now and you'll figure it all out. It's really hard. We've gotten together and spent, Paul and I have spent a lot of days together where we're sitting, and Christine too has been in these of trying to say, all right, how are we going to take the data from this model and put it in this one? And often we'll be surprised that we didn't contemplate how those pieces were going to fit together. And so that's a key piece. And then trying to keep talking to managers about how this is evolving. I think I'm running out of time, so I think I'll go through this pretty quickly, but this is another thing that John Ream is working on of qualitative network modeling, and this is through the U.S. This has been done quite a lot recently of trying to understand some of these relationships and stakeholders. Often this is really helpful to them. We've found of feeling like they can understand what are all these relationships. All right, there are people who don't do math, but they can understand that. All right, if this gets warmer, this is going to shift. And we can capture the scientific and industry knowledge about the shifts. The integrated ecosystem assessment process is another way that we're trying to incorporate climate information. And this is throughout the U.S. There's a national IEA program. These are being done in Australia and throughout Europe as well. But we're trying to figure out how to standardize this in some way to try to learn better of how we're presenting climate information and how it's being received by different stakeholder groups. And I mentioned SIGME, that ACLIME is part of this, as John's going to talk about Ceres, I think now. And no, okay. So there are a bunch of different nodes around the U.S., various projects, and around the world that we're trying to coordinate and work to be sure that the pieces of what we're doing in these types of models are as complementary as possible. And yeah, ask John or Myron or me if you're interested in knowing more about this. This is a new project that is started on the West Coast that Mike Jaycox is the lead PI of, but sort of similar to ACLIME of trying to integrate biological, physical, and socioeconomic models. And there's a big focus on it also of management strategy evaluation. So working with the fisheries to consider different options. And that's the end. Thanks.
Wow. You guys keep busy.
Oh, okay.
Yeah, I know. I was going to ask Australia if they have any questions. Okay, so Australia, are you, Asta and John, you're still there?